My project in Dr. Sapkota's class is focusing on wastewater treatment. To begin, I'm going to be interviewing my parents who own and operate an environmental laboratory in our hometown in Pennsylvania. My dad is a certified sewage treatment plant operator, and my mom is the quality control analyst for the company.
Okay.
Dad, how did you get into wastewater treatment?
I signed up for the Air Force, and part of the duties after basic training was they were looking for mechanics, and I was mechanically inclined, and the CMERT team was looking for people. The CMERT is Civil Engineer Maintenance, Inspection, Repair, and Training. And part of their duties was taking care of all the sewage treatment plants, water treatment plants, Bomark missiles, and other things related to the Sewage building. We went inside, did the maintenance for the big generators. Being that the sites we were at were desolate, I mean, we're out in the boonies, there was no way to have go into a domestic sewage plant, so they had their own sewage treatment plants, in which we had to take care of for them.
So you learned about it here or over in Vietnam?
I learned about it here.
Okay,
and then in the States.
And then you went to Vietnam, and what did you primarily do there?
In Vietnam was strictly drinking water. You had to worry about sewage that went into the streams. There was no sewage plants.
Yeah.
So we just had to worry about the drinking water.
To keep the soldiers safe.
Right, because the water for the Vietnamese, they had no chemicals. They just drank it as right off the stream. So we had to treat the water.
Okay, so
and the ice.
Did you then get back into sewage treatment when you came back to the States?
Yes, I came back and went back to the 1st Air Force again, and that's what I was doing. We took care of all the sewage plants from all the radar sites on the east coast of the United States.
Okay, so
Philly, Greenland, Basin, Gabador.
So that was primarily military places.
Yes.
When did you get into the private sector?
When I got out of the service, I got hired by Bethlehem Mines, and each one of the mines had their own sewage treatment plant. Basically the same thing. They were out in the boondocks, and there was no city sewage there, so we had to treat the sewage for each mine.
Okay. And can you go through the process that sewage goes through once I flush my toilet to when it leaves the sewage treatment plant?
Okay. Once it leaves the home, okay, either like flushing your toilet, using your garbage disposals or whatever have you, it goes into the pipes, and it goes eventually to a sewage treatment plant. Depending on what size the sewage treatment plant is and what is going into it, whether it be domestic, industrial, farming, or what have you, is how the plant is built. Sewage comes in, as we show you right here, Kels, is like is a grit. I'll say a grit chamber. And what that does, the sewage comes in there, and any solid material is ground up so that it passes through that screen, and it doesn't affect any of the equipment.
So it's a physical barrier.
Correct. Okay. And then from there it goes into the aeration tank. Okay. The aeration tank is where the raw sewage comes in, and the mixed liquor, and mixed liquor would be the solids we precipitate and the water that's in the aeration tank. Okay. From there it goes to a settling tank. Okay. And in there is 2 hoppers. The solids settle to the bottom. There's a pump in there that it returns the solids to the aeration tank.
So it gets like a second or third round.
That's continuous, okay?
Okay.
And then from there it goes into the chlorine contact chamber where we disinfect the sewage to make sure it meets state requirements.
So disinfection doesn't occur until the very end.
Exactly.
Okay. And what kind of factors, such as CODs and BODs, how do they affect how a sewage treatment plant is operated?
Basically, a BOD for a domestic sewage, raw sewage, about 350, 400 parts per million.
Okay.
And these plants take care of it by increasing or decreasing the amount of air you add to it, and how much solids you recirculate. Okay, and that's basically what it is. If you go into not a domestic, a industrial, okay, like a dairy, okay, a dairy, their BODs anywhere from 2,000 to 6,000 would play havoc with the plant. This plant can take care of it. So you'd have to go to not a primary or secondary, you have to go into a tertiary type of treatment where you would treat that before you put that into the plant.
Okay. And Mom, can you talk a little bit about what a COD and a BOD is?
Well, the BOD is an analytical test in a laboratory that actually takes 5 days. It's a 5-day incubation period. By 5 days, that plant could have been upset, and you wouldn't have been able to tweak or do what you need for the process to make sure that the effluent can take care of what's going on.
And what exactly is a BOD?
BOD, biochemical oxygen demand. It's how much oxygen is actually robbed from the water.
Okay.
Okay. A COD is a chemical oxygen demand, how much chemicals. It's like a measurement of all the chemicals that are in that particular sample at that time.
That are coming from the outside.
Right. So when you do a COD, it must, in a lab, it must be done within 2 hours. So you can get that, like it's almost like a snapshot type time frame analysis that you can do some kind of treatment or tweaking the sewage treatment plant, that what he would do before that 5 days, so you can get it more of an instantaneous reading.
Okay. And Dad, you were talking about the aeration chambers earlier. So is that the area where you would then put in what you called the good bugs to help settle the sludge?
Right.
Okay.
Okay. Then after you build so much sludge, we take some of the sludge out of there into a sludge holding pond. Okay. So it settles out, and that goes to a sewage treatment. I mean, to a big sewage treatment plant or landfill.
Okay, so that's like the solid stuff.
Right. Yes.
Okay, and the reason that we need the oxygen, why we want a lot of oxygen in this chamber, why do we need that?
Well, the oxygen is it's aerobic type of thing going on here. So you need the oxygen so that the bugs can eat up each other.
So they're aerobic bugs.
Right, they're aerobic, right. Not anaerobic is without oxygen, aerobic is in the presence of oxygen. So if you need that.
So if you have a sample that's coming in and it's a high BOD, that means that it will be robbing the oxygen that those good bugs would need.
Exactly. So that's what I'm saying. It's important that and you keep your plant operating at a interim, I would say, on a 18-20 hour basis. You don't have to add the oxygen 24 hours a day unless you have something come into your plant that's going to rob the oxygen. Then you have to put it on manual, which is all the time. The oxygen's going in.
Okay, and you had said that normally coming from like a residential area, your BOD is going to be around 300.
300, 350. And your typical plant will reduce 85 to 90% BOD.
Okay. What if you had something like a food industry operation, like a dairy, for instance, where you had a very high BOD?
This plant would not be able to take care of it because you're talking 6,000 milligrams per liter, 6,000 parts per million BOD. I wouldn't have enough detention time from the time it comes in till the time it goes out to treat it. So you have to send it someplace else or do a pre-treatment using, increasing pHs, using a flocculant, coagulant, or other chemicals to settle that out.
Okay.
And then you have to go through a filter where you would remove them and have that go to a landfill.
Okay. And that pre-treatment, I know because you are only operating the sewage treatment plant, you wouldn't know what those other places are using. But could those chemicals that they are using to pre-treat affect the good bugs that you're putting into?
No. It would be losing, you're precipitating out the heavy metals and everything else. No, it wouldn't affect that.
So the only place that you could find things that would affect those good bugs are antibiotics that are coming from human consumption.
If that's the case, we don't deal with that because we're strictly, like I say, a industrial plant.
Right.
The municipal plants, like a big city in Washington, place like that, I don't know how they would go about it.
Okay. So it sounds like that everything you've been saying indicates that maintaining a sewage treatment plant is a very complex balancing act.
Yes.
So what happens when something gets out of whack?
Well, I tell people it's not, if the plant gets out of whack, it may take a week, 2 weeks to get back into the actual, you're not doing any pollution to the streams. Like if you blow a fuse in a house, you put a new fuse in, you're right back here. If you unbalance the balance of a sewage treatment plant, it may take days, weeks to get it back in, and in that time, you will be unless you can put it in some sort of a container, you're going to be polluting.
Okay. So what could throw the balance out of a sewage treatment plant?
Somebody throws some sort of an acid into the plant. Well, yeah, not knowing, being that we're an industrial plant right here, you may have a contractor come in, he's doing work, and he throws something down the drain. Unknowns to him, it's going to affect the plant.
Okay.
And then that's why I say daily, we take a daily pH, we take a daily chlorine residual to make sure that we're not polluting the streams.
So when the plant turns, that's called going septic. Correct?
Right.
So when a plant goes septic and you're faced with this, what's the first thing you do?
I can't tell you.
State law, by state law.
That's right. Yeah.
Okay.
No, I try to get the pH up to where we're within. In the state of Pennsylvania, your pH has to be between 6 and 9. Your chlorine residual 0.2, 0.3. Your BOD we're allowed from 0 to say 60. Okay, so if any of those are out of whack, I have to make some changes. Either increase my air, decrease my air, start getting rid of some sludge that I forgot to get rid of, or get lime to bring the pH back up. If we're down around 5, 6, start adding lime to it so we keep between 6, 7, 6, 8, and get the plant back in operation. So we're in good graces with the state.
Okay. So in the meantime, while you're doing all this, what's happening to all that stuff, that sludge and that mix?
Well, I bring tankers in. We take tankers, 3,000 gallon tankers. We'll start pumping out so there is no overflow going out into the stream.
So the stuff that would be overflowing, you're like holding it in the tank?
Yes, holding tanks, yes. So
But-
it doesn't go in. So we don't pollute.
So worst case scenario is that you don't have those and it goes into a stream. Okay, that's not what we want.
No.
Okay.
It's not very conducive. And it's very costly because the state doesn't care what it is. You get a fine.
Right. Do they help you at all, or do they just
No.
like throw fines at you?
Just give me a fine, that's all.
Basically.
All right. So, well, thanks, guys. This was very informative. Anything else you want to say?
Not at this time.
Okay.